Okay, so we have our saved program with reference waveforms in it. I made that with my stator connected 1, 2, 3, so lead 1 to brown, 2 to blue, 3 to black. What I'm going to do now to simulate a fault is put 2 to brown, 3 to blue, and 1 to black. So instead of 1, 2, 3, it's 2, 3, 1. And that should simulate a fault, and we can see how the tester software deals with it. Okay, so run the test. So we're still looking for 20% line-to-line tolerance, which is just the balance, but now we're looking at the test reference waveforms, and we're expecting the waveforms that we generate from this test to be within 5% of each of the references. If not, we'll fail. So we're on lead 2 now. So that's a 17% unbalance, still within our 20% tolerance, and now lead 3. So the waveforms are not shown during the test, they're in the background, but they're being compared to each of the tested phases at the end of the test. So that's the end of the test, and we have a failure immediately. So the message is surge test result is a fail due to compare waveforms. The EAR percent comparing lead under test with a reference waveform is out of tolerance. Okay, so let's close that. The data's been saved, stop testing, and let's have a look at the data. So here we can see the test itself. So these are the 3 phases we've just tested. So the balance is between U and V 17%, V and W 14%, W and U 2%. So that falls well inside the 20% tolerance line to line that we set in the program. However, the message here is in red because it's failed compare waveforms. So let's just look at the pulse to pulse first. Do we have any weak insulation? No. Then look at the reference waveforms. So this is looking at 3 reference waveforms and 3 tested phases that we've just tested. So we can see here that phase 1 compared to reference 1 is 17% different, and the tolerance is only 5, so that's why it's failed. Also phase 2, 15% instead of 5. Phase 3 was okay. So if I turn off leads 2 and 3 and references 2 and 3, you can now see why it's failed. The black waveform is the reference for lead 1, and we can see that the red waveform, which is supposedly the same phase of the next stator, it should compare very closely to the waveform reference, but it hasn't. It's 17% different, and the reference is the tolerance is 5%, hence this failure. So that's how the compare waveform or reference waveform function works. Very useful for manufacturers with non-symmetrical windings, but also equally useful for symmetrical windings, just to make sure that the actual winding going into the stator is of the correct type. We haven't got a reversed phase and things like that. So that is reference waveform testing.